Welcome back. Today we will do numericals based on second law of motion. Let's start. So just I'll revise Newton's second law. Applied force is equal to product of mass and acceleration, and force equal to mass into acceleration. Primarily we are going to use this formula. But equation of motions that we have done in earlier chapter, that also we are going to use here. So the first question is, a truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meter in 20 seconds. You have to find acceleration, you have to find force if its mass is 7 tons. Now you know for finding force you need acceleration, then only you can find force. So the first thing is write given quantities. So I will write given quantities. So a truck is starting from rest, that means your U is 0. Now the distance covers, that means your S is 400 meter and time is 20 seconds. Okay, now which equation of motion you will use to find this acceleration? Yes, second one. So S equal to ut plus half at square. So S equal to ut plus half at square. And when I put this numbers, that is 400 equal to, this will go to 0 plus half, acceleration I have to find, and t square means 20 into 20. So when I do this, I will get acceleration value as a equal to 2 meter per second square. So this is your acceleration. And to find force, force is nothing but mass into acceleration. So your mass is 7 tons. That means ton you have to convert this into kg. So it becomes 7,000. So 7,000 into 2. So 14,000 Newton is your answer. So you see, extensively we are using this equation of motion. So while doing this chapter questions, numericals also, you have to remember all equations of motions. Coming to next question, a stone of 1 kg is thrown with a velocity of 20 meter per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meter. So you have to find force of friction between stone and the ice. This force of friction is given. This is the external force here. So it is given by Newton's second law, that is force equal to mass into acceleration. Now same like previous question, you have mass here 1 kg but you don't have acceleration. So using other quantities and equation of motion, we will find first acceleration. So your initial velocity is, it is given to be 20. So your initial velocity is 20 meter per second. So then it will come to stop. So your final velocity is 0. Distance traveled, S is your 50 meter. No time is given. That means last equation of motion you can use. V square is equal to U square plus 2S. So this will go to 0. So U square is equal to minus 2 into A you have to find. And S is your 50, and instead of this U square you can write here 20 into 20. Okay, so this is your 20 into 20. So when you solve this, what value of A you are going to get? A equal to minus 4 meter per second square, because your velocity decreases. Negative sign is showing that velocity is going to decrease. Now force, mass into acceleration. What is mass given here? Mass of stone 1 kg. So 1 into 4, that means 4 Newton. Okay, so this is your force. Easy. Okay, now moving to next question. An 8000 kg engine pulls a train of 5 wagons each of 2000 kg along a horizontal track if the engine exerts a force of 40,000 Newton and the track offers a friction force of 5,000 Newton. First you have to find next accelerating force and the acceleration of the train. So you have an engine, so that can have force of 40,000 Newton. Okay, and the track, so let's say you have here force of 40,000 Newton, and the between track and this, the force is, that opposing force is 5000 Newton. So now what will be your net force? 40,000 minus 5,000. So 40,000 minus 5,000. So net force is 35,000 Newton. Force exerted by train minus this opposing force. Now you have to find acceleration. Now to find acceleration, first we'll find total mass. So the mass of this engine is 8000 kg and there are 5 wagons each of 2000 kg weight. So total mass, or not weight, total mass will be, there is much difference between weight and mass, that we will see in next chapter. So 8000 plus 2 into 5. This is 5 into 2000. So that will give me 18,000 kg. So now force is mass, that is 18,000 kg, into acceleration I have to find, and what is my force? It is 35,000. So instead of this force I will write 35,000. So my acceleration is 35,000 divided by 18,000. And when you solve this, you will get approximately something like 1.9 or something like that. Just solve it and you can check. Okay, so the next question now. An automobile vehicle has a mass of 1500 kg. So here mass is here 1500 kg. You have to find force between the vehicle and road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square. So here you have to find external force. Here is force of friction. So you have to find force, which is mass into acceleration. Your mass is 1500 and acceleration is 1.7. It was negative, so I am putting this negative. Simply means velocity is going to decrease. So when you solve this, you will get, so this is your answer. So this much force is required to be act on the vehicle in a direction opposite to that of its motion, then only it is going to stop. The next two questions, they are very simple and easy. This too you have to do by yourself. In the first one you have to calculate force where mass and acceleration are given, and the second one you have to find mass where force and acceleration are given.